So you're presented with a derivative or derivatives and integration, two fundamental parts of calculus, which includes limits. And you keep hearing about this word antiderivative. So let's try and investigate what they mean. Okay. So what exactly do they mean? Well, let's say we're asked to find the derivative of x squared. Well, we know the technique we're going to use for this simple function is n x n minus 1, which means our exponent, we multiply forward with our coefficient, and we subtract 1. So in this case, the 2 goes forward, and I subtract 1. So it becomes 2x. Let me do the full calculation over here. So it's going to be 2 multiply 1 multiply x, 2 minus 1. That's how the full calculation looks. All right. Well, now we're asked to find the derivative of 3x cubed. Let's do the same one. Multiply forward. So I'll write the full calculation again in red. It's going to give me 3 times 3 x 3 minus 1. If we do it that way, it becomes fairly simple. 3 times 3 is 9 x, and 3 minus 1 is 2. Now let's look at integration. Well, what if they ask us to find or to integrate 2x dx? Well, earlier I spoke about, maybe not earlier, maybe you watched this video first, doesn't matter. There's a technique we want to use with basic integration, which is x n plus 1 over n plus 1. So let's do that. This just means we're going to add 1 to our exponent, and we want to end this integration with a plus c, please. Okay, remember this one. Remember, plus c. I spelled it wrong. Remember. Whoopsie. So let's do it. I'm going to now say, well, 2x 1 plus 1 over 1 plus 1. If I evaluate this, I get 2x squared over 2. And I can simplify with an 2, so I'm left with x squared plus c. Oh, look at that. X squared. What in the world? It's the same thing as this one. But over here we have a plus c. So let's reverse this one now. Let's find the derivative of x squared plus c. Well, we know the derivative of any constant is 0. So if I find the derivative, let's make a little note. Okay, let's make a note. Let's make a note that the derivative of a constant is equal to 0. So if I attempt to solve this one now, it's just simply going to be 2x again. Why do they seem like opposites? Well, that's for you to conclude, since you've heard this word, antiderivative, right? Let's look at the next one. Let's look at this value. Let's look at finding the integral of 9x squared dx. This is such a bad color. My apologies. Let's use a brighter color. The technique, again, is it's x n plus 1 over n plus 1. Let's do it. Let's say we're going to say 9x 2 plus 1 is 3 over 3. I can simplify this to say, well, that's going to be 3x cubed plus c. Again, let's find the derivative of 3x cubed plus c. That's going to give me, multiply forward, subtract 1, and look at that. Oh, it just keeps giving me the same thing. So for 1, I can use the opposite. an opposite method to find the other one. Do you see why this is referred to as the antiderivative? It seems like when I derive a function, I can underive it by using integration. But underiving sounds awful, you know. So let's use the word antiderivative. It sounds a lot better. Anyway, I hope you have a lovely evening.